This video lesson is about writing equations. You can see here that the student expectation is to be able to write an equation that represents the relationship between independent and dependent quantities from a table. Now, we have looked at equations already, and we have talked about two kinds. We've talked about multiplicative relationships, which are in this form here, y equals kx, and we have talked about additive relationships where y is equal to x plus b. So in this video, we're going to take a little bit closer look at this k in the equation y equals kx and the b in the equation y equals x plus b. So let's take a look at some vocabulary. Two words you need to be familiar with or know, our vocabulary words, are coefficient. Coefficient is a number that is multiplied by a variable. For instance, if I wrote the expression 3x, we understand that x is a variable. And we also understand that since this x is written right next to the number 3 that is being multiplied by 3, well, that makes the 3 then by definition is called a coefficient. So the 3 is the coefficient. If I were to write it in an equation format or form y equals 3x, and again, the 3 is the coefficient. Okay, and then the constant is a fixed value that does not appear with a variable. So, example, you see me write an equation or an expression, that just says x plus 4. All right, so here the 4 is the constant. In this expression, regardless of what we plug in here for x, we are always going to add 4. That makes the 4 a constant. And again, if we looked at that in an equation format, it would be y equals x plus 4. So 4, again, is your constant. So we have coefficients and we have constants. Okay, let's take a look at an example here where we are going to write an equation that represents y in terms of x. So we have our table. Again, this is an input-output table. Let's review some things. The x is the input, and the y is our output. I think I forgot a U here, our input and our output. Okay, but even more importantly, as far as our vocabulary, let's understand that the x is our independent variable and our y is our dependent variable. So the y is dependent upon the x. So let's take a look at just the table here. And in order to write an equation, one, let's see if we can determine if this is a multiplicative relationship or an additive relationship. And what we're doing is we're looking at the relationship between the y and the x. So we have a 1 to 3 and a 2 6, a 3 9, a 4 12, and a 5 15. With the y being dependent, the dependent variable, it is determined by what we're doing to the x. So if an x becomes a 3, that could be 1 times 3. Let's see if it works for 2. Here we have 2 times 3 would be 6, 3 times 3 is 9, and 4 times 3 is 12, and 5 times 3 is 15. So what we have determined is this is a multiplicative relationship, and since they're all times 3, that is going to be our coefficient. We're multiplying 3 times the x. And in equation format, we're going to express the y in terms of x. Therefore, the y is equal to 3x. Whatever we plug in for x, we multiply it times 3, and we will get this table. That's a multiplicative relationship. Okay, let's take a look at another example. And in this one, again, we're still looking at the relationship between the y and the x, or the x and the y. Here we have a 2 that has become a 7. Now, you know, you can't multiply a 2 times a whole number to get 7, so maybe this is not a multiplicative relationship, maybe it's an additive relationship. So if we went from 2 to 7, we could add 5. 2 plus 5 is 7. See if it works for our next ordered pair. We have an input of 4, and 4 plus 5 would give us 9. 6 plus 5 would give us 11. 8 plus 5 is 13, and 10 plus 5 is 15. So here we have a constant of plus 5 each time. So if we're adding 5 each time, and we want to express this express y in terms of x, then the y is going to be equal to the x plus 5. And this would be the equation that we would generate from this table. And again, this is the additive relationship. Okay, here's a couple practice problems. If you want to go ahead and pause the video and see if you can determine the equation that comes from these tables. Okay, so if we take a look at number 1, again, we have an input of 1 that produces a 5. We have a 2 that produces a 10, a 3, a 15. So hopefully you recognize that what we're doing is we are multiplying the input value x times 1 to get a 5, the input of 2 times 5 to get a 10, 3 times 5 to get a 15, and that works with the entire table. So the coefficient is 3, and we're multiplying 3 times the x. So as far as an equation expressing y in terms of x, it would be y equals 3x. Y equals 3x. A multiplicative relationship. Okay, looking at number 2, again, let's just go back and look. We have a 10 that produces a 7. That's a little different. The y is actually less than the 10. Here, an input of 20 produces a 17. 30 produces a 27. What we have here is that the y is 3 less than the 10 in each one of these examples. So we have a constant in this one, and the constant is we are subtracting 3. So if we write this in equation format, it is y equals x and then minus 3. We are subtracting 3 each time to get the output value. Okay, now let's take a look at this practice problem 3. If you want to pause it and go ahead and try and solve it, that would be good. But I'm going to go ahead and work this out. This one's a little tougher. We're not given the table in this one. But let's read through it and see if we can figure this out. This says that Jamie bought 2 puzzles for $5 and 3 puzzles for $7.50. And I want you to write and solve an equation to find the cost of 15 puzzles. Okay, so we're not given a table, but we are given 2 different amounts. We're given 2 different inputs and 2 different outputs. So let's go ahead and put it in table format, since that's what we're learning, and this will help us find an equation. So what we know from the problem is that 2 puzzles were purchased for $5. And we also know that 3 puzzles were purchased for $7.50. So again, what we need to do is see if we have a relationship here between the x and y, or the input and the output, or a relationship between the independent variable and the dependent variable. The dependent variable being the cost. Remember, your cost is always dependent upon how many items you purchase. Okay, so we have a 2 and a 5, a 3 and a 750. Now, we probably can immediately see that it's probably not an addition problem or an additive relationship, so let's check and see if it's multiplicative. And the way you can check to see if it's multiplicative is do the division. Let's see how many times 2 goes into the $5. So 2 goes into 5 2 times. With your remainder of 1 and you bring down a 0, that will go into there 5 times. And you will see that it is $2.50 for each puzzle when you purchase 2. Let's see if it is the same for the 3. So how many times does 3 go into $7.50? 3 goes into 7 2 times. Again, you have a remainder of 1, and you bring down your 5, and 3 goes into 15 5 times. And you will notice that it is also $2.50. So what we can highlight here is what's going to be our coefficient. We are multiplying $2.50 times the variable x, or the input, in order to get the y, or the output. So we can put it in equation format. We can say that y equals $2.50 times x, 2.50x, or even 2.5x. Therefore, if we know this is the equation, we can plug in anything for x to determine the cost. So if you want to buy 15 puzzles, then you would just plug in a 15 where it says x right here. So we would multiply $2.50 times 15. So let me go to a blank slide here and I will solve that.